Hello everyone. We are doing wearable biosensor. So here, this is our entire system. In the middle, you can see this long board. It's the microcontroller board. We're using STM32, which is located at the middle over here, at the center over here. It also has all its connection pins or ports located at the two sides of this board. It's just like this microcontroller board is just like the Arduino Uno board we're using for the microcontroller class. And you can see, or you can also see, we're using this OLED screen to display the data. And this H over here is the heart rate. The O means blood oxygen, and the T means the temperature. And to minimize the size of this entire system, we decided to put the two detecting sensors at the back of this microcontroller. So they're over here. You can see this green chip over here is the DS. Is the MAX 3102, which will use this LED and the photosynthography method to detect our heart rate and blood oxygen rate. And over here, this is DS18B20. It will detect the temperature. And over here, to make it fully wearable, we decided to connect a battery system to the board to power it up instead of connect this board chip to this computer all the time. So this battery system actually comes as a whole, which is TP 4079. So it actually comes as a whole. Yes, it's a full battery system. And I can just use this connection pin and connect them all together. It will just it will power off the system. We basically use the gluting and soldering method to do the connections. You can see over here we used gluting for the connection to power connection port and the temperature sensor connection, and we use the soldering for the MAX 3102 and the OLED screen. So over here, we used both soldering and gluting method to do the connection for the OLED screen. So let me test this. I will move my finger over here. So it will take a couple seconds for it to complete the overall calculation or measurement. Yeah, so over here, you can see my blood oxygen is 99%. My heart rate is around 100. And because I'm talking, so it actually, jumps up and down a little bit. The temperature is around 26 because my hand is pretty cold right now. So this temperature is actually very similar to the room temperature. So I will use my mouth to heat it up a little bit. So you can see over here, after I use my mouth to heat it up, it will come very close to my body temperature. The highest point it reaches to 31 degrees Celsius. Yeah, it will heat it up, and yeah, you can see after a couple of seconds, the temperature goes down a little bit, and it goes back to the room temperature. And that will be this our entire system. Thank you.
So in the process of software programming is the main use of modular programming ideas, respectively for each module debugging, in which all module can achieve its own functions and various modules together combined finally can constitute the whole software system. The design is conducive to the optimization of program code and easy to design and debug. So software system is mainly divided into system main program and subroutine two parts. The main program is responsible for calling subroutine to achieve the function of a whole system. This system is mainly includes initialization subroutine, heart rate, and SPO2 subroutine, temperature collection subroutine, and OLED display subroutine. The software mainly have the function as initializing each hardware, the temperature sensor to measure body temperature, the heart rate and SpO2 sensor to collect the user's heart rate and SpO2 information. So this is the main function of Mac 30102. We modified from the provider of microcontroller. We don't need to change much from the original code, but we add for this example, we add the draft curve function in order to display the curve wave on the LED, which indicate temperature, heart rate, and SpO2 data collected by each sensor in real time. At the same time, the heart rate and the blood oxygen are displayed in the forms of curves for user observation.